Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Hello everyone, hope you're doing fine. Today's topic is etherchannel. Etherchannel is a port link aggregation technology used primarily on CISCO switches. It allows grouping of several physical Ethernet links to create one logical Ethernet links for the purpose of providing fault tolerance and high-speed links between switches, routers and servers. So let's get started with creating a topology. I'm just getting two switches and connecting these switches with two pieces. Before going ahead to implementation of ether channel, we just need to understand what is ether channel and how it actually works. Let we have two buildings, or you may call these as two switches. Generally what we have, there is a link between these two switches, and that single link is responsible for communication between switch 1 to switch 2. Generally we convert this link into a trunk port from both sides, from switch 1 to switch 2, and this trunk port will be responsible for transferring data from switch 1 to switch 2. Let's suppose that we have different local area networks connected with these switches, or you may have a building having different floors, and each floor of the building has different local area networks, or you may have different virtual local area networks, or different routers are different connected with these switches. So all the traffic coming from the different network will pass through that single link, what we call as trunk port. And you may have different local area network. Maybe the local area networks are more than 100, more than 500, or you may have thousands local area networks connected with that single link. So generally there is a bandwidth issue will arise, what we call this is as bottleneck. To overcome that bandwidth issue, we are going to create multiple links in order to smooth running of traffic coming from the different local area networks. Now management of these multiple links is a real challenge for switches. Collectively, this concept is called as ether channel. Ether channel is a port link aggregation technology used primarily on CISCO switching. So hope you guys understand the ether channel. So coming back to the packet tracer, let's implement the ether channel on CISCO switches. I'm creating multiple links between these two switches to implement the ether channel. As we can see here, there are orange lights that will be turned into green in a 30 seconds. That 30-second time is basically listening and learning time for switches. Meantime, I'm giving IPs to these two pieces, which is 10.1.1.1 and the second one is 10.1.1.2. For making sure that there is a connection between these two PCs, I am just going to ping the 10.1.1.2. As we can see that reply is coming from the other PC. Now I'm going to create a continuous ping between these two PCs. I'm putting that -T for continuous ping, so that will continuous ping the other PC. Let's test the connectivity of these two switches by just cutting the wires one by one, just to make sure that there is a communication between these two switches exist. What I'm gonna doing is I'm cutting the wire from here, and I'm just cutting the green lights, the first one actually, the second and first both. Now let's check out the connectivity. As you can see that the request is timed out because there is no connection and still the two lights are orange. So it's waiting for another 30 seconds to just turn this orange lights into green to just enable the communication between these two switches. But the drawbacks of this connectivity is by cutting a single wire or a double wire, you just lost the control of the entire network. To overcome that issue, we are going to create ether channel between these two switches. I have multiple links connected with these two switches, and I'm going to configuration of switch 1. Here I'm going to access the interfaces. Now I have 3 interfaces: fast ethernet 0/1, fast ethernet 0/2, and fast ethernet 0/3. So I need to access all these 3 to make enable communication between these PCs to another PCs. So what I'm telling the switches that interface range fast ethernet 0/1 to 3, access all these 3 ports. And the command for creating ether channel is channel group. This is the command actually used in for creating a channel group. Now when I put question mark here, I can see that CLI is telling me that you can create different ether channels ranging from 1 to 6. So I'm putting 4 here and giving space, and then I put a question mark here. Now he's telling me to add mod. When I put another question mark here, it will prompt a new list of different types of protocols. Now there are 2 types of protocols that are used in ether channel process. The first one is LACP and the second one is PAGP. These 2 protocols are responsible for creating a ether channel between the switches. Now there are different types of modes: active, auto, desirable, on, and passive. So for better understanding of this concept, we are just going to paint, and I'm going to explain that in a great details. The first protocol that are used here is PAGP, port aggregation protocol. PAGP is developed by CISCO. If you are using entire hardware of the CISCO company, so you can use PAGP as your protocol. And the second one is LACP. Now LACP is the other end that is developed by IEEE and if you have different kinds of devices connected to your network, you can use LACP, which is a link aggregation control protocol, and it is developed by IEEE. Now PAGP has two different modes. The first one is called as auto, and the second one is desirable. Similarly, the LACP has two modes. The first one is active and the second one is passive. Now let's suppose that you have two different switches, and definitely there are two ends, and from the first end, if you are using PAGP protocol, and the modes of the PAGP are auto and desirable. So from first end, if you are using auto, and from second end you are using desirable, it means ether channel is enabled. If you have auto from the first end and the second one is also auto, then the ether channel will not work. Similarly, on LACP you have two different modes, active and passive. From the first end, if you have active port from here and you have the passive port from here, then the ether channel is enabled. If you have active on the first end and active on second end, then there is no ether channel between these two switches. Now coming back to the configuration setting, we are on the active, auto, desirable, on and passive. So I'm going to use LACP here. As we can see that there is two modes, active and passive. From this end I'm going to create active and this here on passive. So I am on the router 0 and I'm going to type that active from here. So this port is up. So I'm going to shut down the all ports of the switch 0 and all links are down, that we will enable them later once we done configuration on switch 2. Coming to the second switch, CLIU. I'm on the configuration settings and I need to access the entire port, interfaces, range, fast Ethernet 0/1 to 3. So I'm here inside the ports. So I'm going into the command of channel group, and the channel group is 4 because we have put it that earlier, the same, and the mode will be passive. Now you have different types of modes. You can use desirable and you may have passive. For my case I have passive because the second end is active and I need to put that passive here. Now I am enabling all these ports and changing their state into up. Now coming back to the switch 0, I just need to up entire links of the switch 0. The command will be no shutdown. As we can see here, all lights are red here, and it is actually listening learning times for these two switches. They are just discussing the configuration settings between each other, and as we can see here, the lights are now orange, and within 30 seconds this will turn into green. The concept of ether channel is created for the purpose of providing fault tolerance and high speed links between the switches, routers and servers. So if you have a single link of fast Ethernet that can support 100 MB per second, now you have 4 different links between the switch 1 and switch 2, so you can transfer the data of about 400 MB per second. Similarly, if you have Giga Ethernet, so that can support up to 1 GB per second. Now you have 4 different links between these two switches, so you can transfer the data of 4 GB per second. Okay, all lights are green and the ether channel is created, and if you are in a real environment, you can transfer a larger number of data on this network. So hope you guys understand the concept of ether channel. If you have any question and query, you can write a comment below. You can subscribe to our channel, and please don't forget to share these videos with your friends. So thank you so much for watching this. Thank you.